it's a distance of y2, okay, away from the origin in the y direction. That gives us the point B, which is represented or can be found from the coordinates x2, y2. Okay, so what we're going to do is we're just going to construct, what we're interested in developing a formula that allows us to calculate the distance between 2 points in space. Okay, so we have a point here, a point here. We'd like to be able to calculate the distance between those 2 points, or more importantly, the length of a line segment given 2 points. That's really what we want to be able to calculate. So what we'll do is this: we'll continue this point out in this direction. In other words, we'll create a line that's parallel to the x-axis. Okay. So what I'll do is I'll continue this point out in this particular direction here. Okay. So we'll just continue along here until it intersects this particular vertical. I should have actually said that what we're doing is we're dropping a vertical from the point B, and we're dropping a vertical from the point A that's perpendicular to the x-axis. So just to keep that in mind. And now what we'll also do is we'll continue this particular point from B down along this particular vertical until it makes this particular intersection. So what we have is we have an angle here which is effectively a right angle. Okay, and the question is, can we figure out what this particular length, the length of this particular line segment AB, the distance between points A and point B is? Okay, that's important. So now just keep in mind that the distance between A, let's actually call this other point here, this point C, okay, this point here, the point of intersection of these two, the vertical and this horizontal. Okay, the distance between A and C, okay, is effectively this distance here. So the distance is, this distance here is the distance between the point A and the point C. Okay. Now we know that the point C is x2 units away from the origin, and the point A is x1 units away from the origin. So this distance between here and here must be x2 without x1. Okay. So if you think about it, this distance here is effectively, let's just say it's this distance here, x2, okay, and it's without the distance x1. So if I take the distance x1 away from x2, what I'm left with is the distance between here, okay, so which is effectively the point x2 minus the point x1, okay, or the value x2 minus x1. And similarly, we have that the distance between these 2 points here, okay, between B and C, is, well, the point B is, let me get my black marker. Okay, the point B is, it's y2 units. It's y2 units away from this particular value here. Okay, it's y2 units in the vertical direction. And the point C is, well, it's on the horizontal, so it is y1 units away from here. And once again, if we take the short line away from the long line, what we're left with is the distance between here and here, which is effectively, it's effectively y2 minus y1 here, okay, is effectively the distance between the line segment B with C. So actually what we have now is we have a right angle triangle, okay, and effectively what we have is that we know from Pythagoras, okay, that this particular distance, this AB, is the same as, it's the square root of AB, okay, the square root of it, the length AB. Let's put this down here. So we have the square root of the length AB, the square root of it must be equal to the square root of the length BC. Okay, now the length BC is y2 minus y1, so it's the square root of that, it's y2 minus y1 is its length, okay, squared, plus the length, this plus the square root of the length AC, so it's the square root of this length here, and that length is x2 minus x1, so it's x2 minus x1. So what we know is that the square root of the length AB is equal to, oh, that's squared here, is equal to the sum of these two squares, okay, which implies that, I suppose, that the length AB, okay, is the square root of this, because if I get the square root of this, okay, the square cancels with the root, and I'm left with, it's the square root of y2 minus y1 squared plus x2 minus x1 squared, and it's the square root of that there, okay. And we've probably seen this formula written, don't forget, addition is commutative, a plus b is the same as b plus a. We've probably seen this formula written as, we've written down this distance first, which is x2 minus x1 squared plus y2 minus y1 squared, and it's the square root of that. So what we actually have here is that the length AB, or that the distance between 2 points in space, okay, the point A, which is x1, y1, and the point B, which is x2, y2, okay, given 2 points in space, their coordinates, we can calculate the distance between them just solely relying upon the values of their coordinates. Okay, guys, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope that this short video, another video in our series dealing with coordinate geometry of the line and trying to rationalise where the distance formula for the distance between 2 points comes from, okay, or for the length of a line segment, given the 2 points that are the ends of the line segments. I hope that this video was in some way intuitive. And more importantly, I hope that was helpful. And thank you for watching. Okay, bye bye.